So today we are looking at 6-5 inequalities in one triangle. Our essential questions: how are the sides related to the angles of a triangle, and how are any two sides of a triangle related to the third side? So we start off with two theorems about our side and angle relationship. One is basically the converse of the other. Our first one, triangle longer side theorem, says if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So when we're looking at this triangle, ABC, AB is 8, BC is 5, so clearly AB is bigger than BC, which they tell us. What that means is that angle C, which is opposite AB and the 8, is larger than angle A, that is opposite BC and the 5. I can't say anything about AC and angle B. I know nothing about their side length, or angle measurement. Then we have the other theorem, the triangle larger angle theorem. This says if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller one. So we're looking at this picture, 50 degrees is bigger than 30 degrees, so angle A is greater than angle C. That means that BC, which is opposite the 50, is greater than AB, which is opposite the 30. The difference here is I could find that angle B is 100, and I now know that AC is along the side. I can do that when I have angles, because I know my triangle adds up to 180. I can't do that if I only have two sides, because I don't know what the triangle adds up to with sides. So looking at our examples, example 1, list sides and angles in order from smallest to largest. Make sure you're doing everything they ask for here, make sure you're putting them in the right order. So you're going to have an easy part of this and a harder part of this. The easy part being the numbers they give you. So in this case, they give me angles. So in A, angle P is the smallest, that's at 45. Then angle R at 55, and then angle Q at 80. So opposite P is QR, so that is my smallest side. Opposite R is PQ, that's my medium side, and then PR is opposite Q, so that is my largest side. In the second triangle, I have 70, 90, I don't have anything at R, but again, my triangle adds up to 180. So I can solve for this and know that angle R is 20 and is then my smallest side. So angle T is middle, and angle Y at 90 is the largest. So again, opposite that 20 is TY. So that is my smallest side. Opposite the 70 is YR, and is my medium side, and TR, my hypotenuse, is the longest side. Example 2 asks us to sketch and label the triangle. It tells me I have side lengths of 3 meters, 7 meters, and 9 meters. Angular measure is 16, 41, and 123. What I want to start with is the other information they give me. The longest side is on the bottom. So I know I have my longest side on the bottom, which is 9 meters. The smallest angle is at the left, right? So my left side is over here. That is my smallest angle, which is 16. So then I'm filling in my other things. Okay? I know I have a side that comes down here. That's opposite the smallest angle of 16, so that has to be my 3 meters, meaning the other side has to be my 7 meters. Opposite the 9 meters has to be the biggest angle, which is 123, so this is 123, and then that leaves 41 for this angle. When I'm grading this, I will grade it by how it is labeled, not how it is marked. So if your 7 meter side looks smaller than your 3 meter side, but it's labeled correctly, that is what I'm going to judge it by. Then we have the triangle inequality theorem. This relates our sides within one triangle. So what we're just looking at relates sides and angles in one triangle. This is just looking at the side lengths. So the sum of lengths of any two sides of a triangle is greater than the length of the third side. So any two sides that I add up have to be bigger than the third side. So here they give me AC to start. So AB plus BC is bigger than AC. AC plus BC is bigger than AB, and AB plus AC is bigger than BC. This lets us do two things. One, I can compare and see if things are working. Right? We can also find a range of sides. But when I'm checking to see if it works, realize basically I need to add the two smaller ones and have them be greater than the third one, because the largest side is always going to be bigger than everything else. So that's the first thing of examples we look at on the other side. Example 3, is it possible to construct a triangle with the given side lengths? If not, explain why not. So I'm adding my two smaller ones to see if they're greater than my third. So starting with the first one, I have 5 plus 7, that is equal to 12. 12 is not greater than 12, it's equal to 12. So this is no. And that work is my explanation. B, 25 plus 90 is 115. That's greater than 100, so this would work. 4 plus 5 is 9. That's smaller than 10, so that does not work. And that is how we check to see if it is possible to construct a triangle with the given side lengths. The other thing we do that with that example 4 is find the possible range. So A gives me 14 and 10 as my two sides. So my third side is going to fall between two values. The best way to find this is add addition and subtraction. 14 minus 10 gives me 4. So 4 plus 10 isn't going to work, but anything bigger than that will work. Also, 14 plus 10 is 24. 14 plus 10 has to be bigger than our third side, so 24 doesn't work, but anything bigger, anything smaller than that will. So B, 23 minus 17 gives me 5. 23 plus 17 gives me 40. So that is my range. On C, 15 minus 10 gives me 5. 10 plus 15 gives me 25. That is the range that X can fall between. The only way we can make this more complicated is putting an X value in for one of those that has numbers associated with it, which is what we do for 5. There's ways we can make this even harder, but this one is fairly straightforward. I'm trying to find my possible values for X. So I start with 2X minus 2. Then I want to find the range that could be in. So I do the same thing we did up on example 4. 7 minus 5 is 2. 7 plus 5 is 12. So that's the range I need to fall in. Now I solve it very similar to my equality. I just have to do that on both sides. So I add 2 to all three sides. So I have 4 is less than 2x, which is less than 14. Then I divide by 2. 2 is less than x, which is less than 7. And that is my answer. Another thing that could complicate this is if we had a negative, our signs would switch when we multiply or divide by a negative. But for right here, we don't need to worry about that. Then on the note sheet, there is stuff about indirect proof. Right now, we are not going to worry about the indirect proof stuff. We will end there and just look at the inequalities in our triangle. So you can ignore the rest of the notes.